Welcome to the Structural Engineering Podcast. This is episode number 4.
Yeah, we made it to 4. Can you believe it?
Losing counts of 4. Bad sign for the future. That's all right.
Oh, no.
This, the Structural Engineering Podcast. My name is Max.
And I'm Zach.
Every week or so we get together and talk about structural engineering. Sometimes technical topics. So far, some introductory stuff, but we're kind of going to dive into everything. Do some interviews, a little bit of everything.
I want to put you on the spot real quick.
Yeah.
We haven't talked about this. In the first 3 podcasts, what have you learned in podcasting? Like in this platform?
In this, make sure it's recording.
Okay.
That's a personal thing I learned.
I know, yeah.
Talk louder than I usually do.
Yeah. Our last podcast, I had to up it like 300%.
Yeah.
And you can tell.
Yeah.
So we're learning. I mean, every week is new, and you don't know until you know, right? I mean, I think that just like engineering, you don't know until you know, and so I think that kind of jumps right into our first topic. That I wasn't planning on segueing that, but
that's a good
it worked
segue,
out.
actually.
Yeah, it jumps into like what we want to talk about today, and that's I think like the biggest things you learn as a new engineer, and like what you do today.
Yeah, what are the most valuable lessons that you learn in your first several months, like your first good engineering lessons, takeaways
that you
apply
back,
for the rest of your career.
Yeah, and
things
you look
that
back
become
now,
very important.
You'd go the people I'm going to train. I'm going to teach them these things, like 100%.
Yeah.
So, okay.
All right.
I'll kick it off?
Kick it.
Okay. I'm going to start with the very non-technical part of it, but I think just having, like, good calcs.
Yeah.
And I think a big one is like, having other people be able to, like, go through your calcs and, like, completely track it.
And probably with good calcs is like a good outline of your calcs, not just like nice clean numbers that you could submit as homework. And
no.
It's like
going to the 12th digit and people are asking. Okay, this is good. Not segue, but I was reviewing someone's calcs the other day, and I said, okay, it was an elevator rail, and they only allowed an eighth of an inch, right, 0.125 inches of deflection. So I had another engineer calculate for me. He calls me up. He goes, so the problem we're having is it's actually deflecting 0.1256. And I said, what's the problem? And he goes, it's over deflecting. I said, do you know how minuscule that deflection is? I don't know.
What's the thing? What is it for? Is it for
elevator
like partition?
Rail.
Oh.
Yeah, it can only deflect an eighth of an inch, and it's deflecting 0.1256.
Well, it was like an MRI, right? That thing was like 0.000 and then some number.
I did one the other day. It was a 16th of an inch, so 0.0625. Yeah.
Enough size measure.
Anyways, all right. I think that's something though new engineers do is take way too many significant figures.
Oh yeah, for sure. But even just like besides your single calc on everything, like going in with a calc packet right off the bat. Like wherever you get your wind load, unless it's something like unless it's your local, where you do a building all the time, I'll like PDF the municipality's code and just drop it in a folder every time. Yeah. Because if you don't, and like maybe you're wrong, maybe the code updates, like you need to know where you got that info. No matter what.
Yeah, and I think like having your calc pages fully filled out. So for like all the experiences I have, it's project, subject, project number, or whatever, and then like date and name, like on every calc, no matter what.
Yep.
Because you know exactly what project it goes to, you know exactly what it's for, and I don't do that all the time. Like I try to do as much as I can, but sometimes I just do some quick calcs and I see it later.
Yeah.
And I'm like, I have no clue what this is for. I don't know what the project is for. I don't know why I'm doing it.
I'm a big fan of like the title page, and I've been trying to do this a little bit, but we don't pick up too much. But like, handwritten, so it wasn't in there from your last Excel document. As soon as you start the project, who's your contact, owner, building code, wind speed, seismic, and then it's there every single time. A summary page that can't be accidentally duplicated, and that just kicks it off no matter what with a nice clean set of numbers.
Yeah, and
someone can start tracking your calcs.
Right, and I think it's important to have like a solid set of calcs too. Like there's obviously that 90-10 rule, right? But when someone's QCing it, reviewing your work, and they start asking questions, you're like, boom, here you go, right? And like you've thoroughly thought through everything. I think that's important. And then like if you have a municipality that wants to review calcs, you've got calcs to review.
That's
so
true.
I think just the big thing there that I learned early on is just being organized.
I think that's a good one.
Just being like that goes generally in life.
Just always.
Just always be but the first firm I worked for, the guy that founded the firm, I guess he wasn't there anymore when I worked there, but he was known to go around on Friday afternoons when everyone left, and if you had calcs on your desk that didn't have the title, your name, the date, like everything filled out in it, he would just throw it away.
That's kind of mean.
Yeah, he'd just throw it away, and because he said if you don't have it filled out, obviously it's not for anything.
It's pushing it a little bit.
I think it's pushing it, but
yeah, I get
definitely pushing it. But I get the reason. I mean, there's just if you're doing the work, it takes 5 seconds to put your name on there and what it's for. So just being thorough and being able to track what you're doing.
I've got one for you. This is something I actually took from architecture. A lot of anything in my head is usually like one-liners from somebody. This is not a one-liner joke, but this is an architecture boss when I was putting together a set of drawings that just looked like junk.
Yeah.
He said, the only thing that we provide is an instruction set. All the effort we put into this is meaningless. The only thing that you hand over is 10 pages of instructions on the whole building.
Yeah.
Or whatever, 20, whatever it ends up being. And that your drawings have to be exactly your intent, as clear as possible, go overboard, not underboard.
Yeah.
Yeah. That's
I know we're talking
the only thing of value is that piece of paper.
Yeah, that's your deliverable.
That's your deliverable.
Yeah. For us, sometimes it's also the calcs.
Sometimes they have to see the calcs, but like the construction team, the only thing they're going to see
is the drawings.
A couple pages of paper. Yeah. So if that's not conveying your message 100%, then you might as well not even do it.
Yeah, absolutely. I think that's where most people probably get in trouble. It's not putting everything in there.
Yeah, definitely.
That's a whole nother conversation. I think
you'll save time. Yeah. Good drawings.
I think if you have, it's another good segue right to our next thing. And I think we kind of talked about this a little bit, is load path. And if you don't have good drawings that prove good load path, you don't have a good building.
That's a big one. That's a hard one to. It's not hard to describe, I guess, but that's like a deeper subject. Load path in general, but I think super important.
You're building, you get the loads. That's another whole thing. But you get the loads, and then just track your loads.
How would you describe your roof?
How does your load get for? Let's say gravity load on your roof, right? How does that get to the foundation? If you can track that all the way down, then you have good load path.
Yeah.
The big thing that I've heard a lot and was kind of really instilled to me as a new engineer is if you have load path, it'll work. The load will find its way there, relatively, right? Mm-hmm. Like, if you have a column way over there and a beam way over there, it's not right. But if you have a good load, if you have load path, bad things won't happen, even if it's not sized perfectly. And that's a big one, I think, in seismic design as well.
I think that's something that's really left out in residential design. Is that you design everything as its separate component, and you do not even consider how loads transfer through. I'm like, jumping immediately in my head to roof systems, where, early engineering for me, it would be like, this is I guess, we're not sizing trusses here, but like the truss connects to the wall. No details showed that.
Yeah.
Down we go. And that is not a system. That's hoping for the construction workers to do a good job.
Yeah. What's one thing I see missed all the time with wood construction, like housing and like even some commercial, is that they don't think, or they don't detail. Maybe they're hoping that this comes from the truss manufacturer, so it could have. Yeah. It could be, but is truss blocking to get your load from your roof down
that's exactly what
your shear wall.
Truss blocking.
Yeah. That's missed all the time.
Yeah.
And so that's right there is load path, right?
Yeah.
If you don't show details, you don't show truss blocking, then there is no path for your shear loads to go.
Your rollover.
If you show something there, you at least have a path. Yep. Even if you put in, really anything, plywood would transfer your loads.
So how, so as a lesson, how would you know for sure that you have good load path? Like, what would be your procedure, especially like early on when your boss would say, "Do you have continuous load paths?"
I think
you would go in your head and you like run through the building, pretend you're a little bit of load, like.
Yeah, that's a really hard one because I think a lot of it is just learned, and like it's one of those engineering judgment things of where like you've done it not before, but you get that your load has to go from your roof diaphragm. Let's say for lateral loads, that load has to get from there to your wall. So to me, it would be like one horizontal element to your vertical element, getting that load down. How's that happening, right? And so I think that's like a quick check. Is there something there that will transfer those loads? Check, right?
Yeah.
Okay, now they're in the shear wall. Okay, let's say wood shear wall. How does that wood shear wall take its loads into the foundation, right? Okay, now it's got sill plate anchorage and it's got hold downs. Okay, are those there and those detailed? Yes. Okay. And then you're at your foundation. Is there soil? Just looking through the whole system. Is there soil underneath? Okay, yeah. Look.
Rebar to hold the embedment.
Yeah, and like let's say your soil bearing doesn't calc out to work. The load's still going to get there. You're going to have some settlement, some deformations that you're not expecting, but it will not fail. Your building will still work relatively. I'm not going to say you can underdo all this stuff, but
if you have,
if you have good load path, yeah,
it will find
its way.
Find a way.
Yeah, your house maybe will slide a little bit, but
that is its way.
Or someone else's house because you might design someone else's, but. For that example, I don't think you see anything like to that extent of your house sliding. Yeah. But I think if you can just think through those steps and like a gravity beam, right? Let's say a composite deck system, metal deck over beams on a roof, right?
Yeah.
Got some snow on there. Well, your snow is going to sit on your deck. Okay, is your deck designed to span between two beams?
Better be.
3 beams, right? Okay, cool. It does. That works. Okay, can your beam support that, right? So like you're just tracking load from your deck to your beams. Can your connections of your beams take it? Yes. Can your girder beams now take that load?
Mm-hmm.
And then can I don't think that necessarily needs to be to that level, like every beam but like that's what you're looking at is designing those individual elements to transfer that load through the building.
I heard something a little bit ago referencing the Northridge earthquake, which is, I think, 1989, right? Something like that?
88 or 89, yeah.
And maybe this is something that you had mentioned a long time ago, but one of the investigators after the earthquake, when they really updated a lot of seismic codes, said that everything fell apart in the order or in the way that it was probably designed. Like the roof was totally held together, but it was no longer attached to the walls.
Yeah.
The walls were all standing, we're all solid, but they weren't attached to the other walls. It was like every component fell apart individually. And that is exactly, load path.
Discontinuous load path. Yeah.
The designer's like, all right, here's a wall. We got some wind. We got some vertical loads.
Yeah. But tying all those elements together. Yeah.
Yeah. Yeah. If you don't have every connection, you don't have anything.
Right. Yeah. I think that, yeah. And so just good load path. Like just, how does your load get from A to B, A to Z? Track. It has to go somewhere. And I think that's where people get in trouble. Is like not thinking that through.
Yeah.
I think that's like the number one way to get in trouble. Is not thinking through the load path.
Yeah.
Is that, yeah.
Yeah.
That's something you learn as well.
Oh, yeah.
I think everyone just learns. The first job, there was everyone at their desk, like all the new guys had just a piece of paper that said load path, load path, load path.
Oh, that's a good sign.
Yeah, and you're just like, we're supposed to remind you every day. And there's always a joke around the office, like, got load path, dude. Like just, yeah. They're probably listening to this.
Probably not. If this is the first one, they're like,
I think so.
Never mind.
Yeah. Anyways. Yeah.
What else you got?
I can't remember.
You mentioned in our pre-screen discussion something about mentorship.
Yeah, sure did. I think it's important.
Yeah.
I think it's important. Man, we should have beer. I don't know.
Yeah.
Or adult beverage.
The other thing we've learned in the podcast world is when do you not plan what your podcast is about. Sometimes you just try to shoot from the hip. I mean, that's kind of like the three biggest things. Yeah. Mentorship, like, yeah, that's definitely super important, but that's not something you can necessarily improve once you're in the working world.
Yeah.
Like the things that you need to have.
What's your experience with mentorship? It's been there some days and it's not others. I mean,
pretty light.
I without explicitly, whatever. But like importance. Like, have you found that when you weren't being mentored well? I mean, this is so obvious, but that your work lacked. You didn't know you're doing things right or wrong. I mean, what to you? Why is having a good mentor important?
Important, yeah, that's a good point.
In engineering specifically, because in life it's good to have mentors.
Yeah,
I mean, in general, of an older soul that's gone through stuff.
I think having someone direct you in engineering allows you to work hard enough that you learn well, but not so hard that you are just doing nothing. Like when you don't understand a topic or, whatever it is you're working on, you want to be able to struggle a little bit because that's how you learn, right? You want to like read into the code, whatever it takes to figure out this problem that you're having, whatever it is. But if you don't have the resources to then, after 30 minutes of this say, hey, can you explain this? Then you're I think in trouble. Like,
yeah.
You need good backup, but also a bit of space. I think that is what a mentor is supposed to do for you. And probably like dive into topics a little bit more when you're, like give good personal stories that go with what you are looking into. That's not the sentence I mean. Yeah. Like just being able to dive a little deeper, explain why something, right? Like I can't ever remember anything unless I know why. I just totally forget, right? So it's like I think that's almost as important. If you find something in code, you're having trouble, you track it down. To have someone that will explain why it is the way it is really helps solidify things.
Yeah, absolutely.
So that's to me the role of a mentor.
When you turn into being a mentor for a younger engineer, that's one the biggest thing. Like, kind of showing why and helping explain rather than saying, they're like, I need to know, or how do I figure out these loads, and just say, I'll go to that chapter, figure it out. But you help them kind of through it a little bit, and then you explain like, oh, back in my day, when loads were easy, and now they suck and they're confusing, but like. Help walk through.
It's like one part you're being bumpers like when you're playing bowling. Like you just keep them in this lane without too much, you just push them back in the right direction and let them continue on. But
I think a good mentor will like let you fail. Oh yeah. Like not in the sense that the project a building or like a bad drawings or calcs go out, but in the sense that like they'll let you
learn a lesson.
Do it first and then be like, that is absolutely wrong. And I think sometimes you have to go through the motions initially to really like be able to learn from them once they try to correct what you're doing. So I think that's really important to get that space, like you're saying, and get a mentor that's like, okay, go do it. And then come back and then we're going to do it again, and kind of give you that freedom. And like we kind of talked about before, is like having firm that is big into education and growing and growing you as a professional, and that gives you that space, to kind of take off and keep growing, fly, big wings, chicken wings. So I think those three, I probably think about quite a bit.
Yeah, I really think clean Calyx, load path, and like drawings being your only value, like just having that in mind is so that's enough.
So I'm curious. Important. This is different than those three, but when you started being an
engineer,
what did you think your role or interactions would be with architects or clients? Did you realize that those would be your clients? Like, did you know?
I was an architect before I was an engineer. Yeah, I guess I did know that, but
so like you understood how that whole world
I did.
worked.
I grew up doing construction.
Okay, and then when you started as an engineer, did did you kind of get shocked? I guess not, because you were already an architect, but like you just all of a sudden got thrown into these meetings and kind of just hit it rolling. I mean,
I had a slow introduction, because
okay.
I did like a lot of handyman kind of stuff when I was young, and then I did construction, and like you kind of edge into this sort of thing.
Yeah.
Were you shocked? I feel like with the question, you must have been a little.
Yeah. I got into some meetings with some pretty high up people pretty fast that I didn't expect. I was probably given too much freedom to go to some meetings that they were like, "Where's
the adult?"
Where's the adult? More or less, and getting in these meetings with like owners and stuff. It
can be intimidating, no doubt.
Very intimidating, and the whole not anymore. I think I can talk for myself pretty well in these meetings. So, but like when you're new and you're like, I'm still learning how to even do anything, and they're asking you these big questions, and you're like, I'll have to, I think it's okay to say I'll get back to you, and it's the best thing to do. You should never lie or say you know something, but. It just blew my mind like how quick I got into that. Like not saying
that's probably unusual. I think most firms, especially any sizable firm, it's something like a Hewitt or whatever, like anything big, I assume you're not in.
Yeah, if any of you guys work for any large firms,
I'd
love to hear. Because I think
maybe we're entirely wrong.
I mean, it was probably 2-3 months in, all of a sudden I started going to these meetings. I think that's a big important thing with a mentor is going to these meetings with like your mentor or someone that's like higher up that wants to help you and walk you through how all this works. Because I learned a lot by going to these meetings and going, so we work for the architect. The architect then kind of works with the contractor, but they're hired by the owner. Contractor's hired by the owner. Like there's a lot of players, and you start realizing on some projects you gotta keep some people happy. And you have to kind of understand where the money's coming from.
Choose who you keep happy, unfortunately.
And kind of, your goal is always keep everyone happy, right? It doesn't always happen. But I think understanding how all those roles play, because there's so much politics.
Yeah.
I mean, this is all politics between everyone, all the time. The owner's like, why can't you do this? It doesn't work. They're like, no, it works. No,
I saw it.
Yeah, you hired me. But not that happens. But.
I would assume for most people, you probably don't get into this until a couple years in.
If you can, definitely do it. Just even go to meetings and sit in. I was talking to an architect the other day that's like 2 years in, and he was telling me that he's been going to these like owner meetings and stuff, and I think that's probably more probably happens more often for architects and younger architects, but he was talking about how he's kind of confused that he goes to these meetings. He doesn't say anything, he just sits there. And his mentor
do a lot of that
there.
actually.
Yeah,
a lot of note taking. At that point though, it was totally understood that I was not to say anything.
Yeah. And his mentor was there, and she was telling him like it was kind of interesting. He didn't realize like why he's in these meetings, but she's like, you're there so that in a couple of years you can run these meetings. Like you're only going to learn how these work by sitting in here and listening to higher ups talk, and go through the paces and experience. It's just good mentor with good experience can get you far.
Boom. I like it.
Yeah, I like it.
Those are 4 takeaways. I think we
three
and a bonus.
Yeah.
If you have any takeaways from your first experiences, the things that are most valuable to you, the big lessons of engineering early on, let us know.
And if you design this building, we'd love to talk to you. Also, if anyone
a seat right in between us.
If anyone knows what building we have in front of us, I know a lot of you are listening and some are watching the YouTube video. But if you know what building this is, let us know and maybe we'll give you a little shout out.
We'll scream your name.
We'll scream your Yeah. No, I think maybe we start putting new buildings up.
Oh, yeah. That'd be fun.
Maybe we get a whole building.
Till we're skyline. Just behind.
We're like peeking out behind skylines. But yeah, I think over the next few weeks, you'll see some more technical videos coming out. We're pretty excited about a new series we're starting. You want to talk about this new series?
Yeah, we're going to do a mini series, a history sort of one.
Yeah.
This is getting into the history of structural engineering.
Baseball.
Going way... No.
Oh.
No. We're doing structural engineering.
Oh. Good. I don't know baseball.
Going way back, starting with the first structural engineers.
Yeah.
Moving our way up to modern times. I think it'll be kind of fun.
Yeah. Wait, how many? What do you think each video or podcast will go over?
Maybe
like a time period, a person?
An era. I think some probably an era.
Okay.
Like go.
Yeah.
I don't know.
We'll start with the pyramids.
Yeah, we'll start with pyramids. I don't. There's not much in between pyramids and like England.
Yeah.
Romans, pyramids. We'll tie pyramids in with the Romans.
Okay. Talk about some arches.
Talk about some arches and some aqueducts and some bridges and some. They have a 110-foot bridge still standing. The Romans.
Wow.
No, nuts.
Different occupants. They put cars on it now.
No, just people.
Okay. I could get that.
Well, that's
long.
That's a big bridge.
110 years.
110 feet.
Oh,
110 years.
2,000
years.
I was gonna say that. Yeah, that doesn't make sense. Oh man.
And we'll go all the way up to new developments.
When are we gonna start that series? New Year?
Right. Yeah, New Year would be good.
We'll start off the New Year with that series. We're looking to probably have that concurrent with our typical podcast.
Mm-hmm.
We'll maybe do 2 a week. Some weeks we'll probably have one, but
yeah.
So any of you guys that aren't interested in the history at all and kind of want to stay with maybe technical topics or
zone out.
Yeah, zone out. Or we'll have maybe some other videos, podcasts. So I don't know.
Cool.
We just want to party.
Yeah.
Yeah.
Oh, and the ice one.
Oh yeah.
And also around the New Year we're gonna do podcasts on ice structures. We've been doing some testing.
We've been doing some testing for sure. We have a lot of tests in my freezer.
Some material properties underway. Yeah. We're building an ice house.
We're doing very technical testing.
So stay tuned for those things.
Yeah, we gotta make a rig.
We got some cool stuff coming up.
I got some ideas we need to talk about after this. But anyways, if you guys have any questions or comments or just want to chat with us, we'd love to chat with you guys and maybe have some dialogue.
Yeah, and got email in the show notes, Instagram, show notes, Facebook.
Yeah, everything's in there. You're not.
I don't even have a Facebook.
That's okay. So I'll talk to you on there. Max can type on there too. But anyways, reach out to us and thanks for joining us this week.
See ya.